Hello everyone. This is the video presentation of my data science project for the capstone project of Coursera. This is the rubrics that I'm going to follow in my project. Here is the IBM Cloud platform where I'm going to run my assignment. The first point is use case. So my use case is to predict the road quality using decision tree based methods. In this project, we predict the quality of the roads. We classify the roads mainly in three types based on their existing condition and structure. We have three types in this case: carpet roads, bumpy roads, and rough roads. Data set. I collected this data set by myself. I mounted a smartphone in a car and recorded the data with the help of a simple web application which can be downloaded from App Store. Uh, After the collection of the data, I did some pre-processing, which I'll talk about later. And let's get started. For a little overview, I uploaded my files in the Cloud database here, as you can see. Let's get started. The first file is my positive dataset, which are labeled as 1 here. The first three columns represent the accelerometer data, and the second three columns, xg, yg, and zg, represent the gyroscope data. Assigned a data frame, just installed Keras for neural network, importing some libraries, and now visualizing the data. I printed out the head and the first 10 entries popped out, analyzing the tails, and I printed some parameters, for example the mean. As you can see, the x column, which is the accelerometer data of the x-axis, has a value of minus 0.3438. Similarly for each of the column. Then again we have standard deviation and minimum and maximum value. Data quality assessment. So for the data quality assessment, I used different plots, as we'll see later. For the rubric 4th point, data exploration, for example, correlation between columns. Here is the calculation of the correlation matrices between different columns of the data. Here you can see the x-axis and y-axis have a correlation of minus 0.16. The x-axis and z-axis have a correlation of minus 0.06, and the y-axis and yg-axis have a correlation of minus 0.012. If we can find a correlation matrix for another two columns, for example z and xg, let's see what we get. Run enter, and we get is minus 0.015, which is pretty low, so we can assume that they do not affect our final results. Collected some info, and now coming to data visualization, that is the value distribution of columns. I plotted the histogram of the different columns of the data. As we can see here, this is the histogram of the accelerometer reading of x-axis, which can be seen, which is approximately centered around minus 0.4. Similarly, y-axis, which is centered about 2. Similarly, z-axis, and for the 6 columns that we have. Now I'll add the data of bumpy and rough roads. Let me check if it is recording. correctly? Okay. So negative examples, we added negative examples, we labeled them 0, and we get this column. Similarly, as we did with the positive instances, we do with the negative instances. We plot different information, and then we plot this data. Now, there is one catch here, because I processed each column individually, and the output is an array, so we have to convert this array into a data frame, which is pretty simple. For now, we are just stacking the result, the carpet road data and the bumpy road data, which gives us an array, and we can calculate, we can transform the array into the data frame by using pd.dataframe function. As you can see, it has 7 columns, the 3 columns of the accelerometer data, 3 columns of the gyroscope data, and 1 label data. As we run and store this into the column, into a data frame result 1, we get is a combined data for passing through the classifier. Then we separate our data set, that is XYZ, XG, YG, and ZG column. Rubric number 5, at least one feature engineering, etc. imputing and missing values applied. Uh, this might be applicable if I recorded some data or downloaded data from another website. My application was very good in recording the data, so it didn't miss any value, so it's not applicable here. And let's go to the rubrics down and see. So we get now is F1 score and model performance. So let me walk you through this. This is the feature engineering. I scaled the data, I defined a function, used the min-max scaler, which restricts the value of our data between 0 and 1. We do this because large values can cause the stochastic gradient descent to explode when finding the minimum loss function. We used this data, scale data, pass the array x, data frame x, and we stored it into normal data, and then we converted again this into a data frame, because after passing it through a scale data function, it gave us an array. In feature pre-processing part 2, I applied a low pass filter which removes any unnecessary noise. As we will see here, there is a lot of noise in the data. For example, this one, as you can see, signal sample Y and signal sample Z. I first tried without applying the filter, and it gave a very low accuracy, and after using the filter it gave a high accuracy, around 89%. I plot my data, I applied the filter to the X column, again applied to the Y column, applied to the Z column, XG column, YG column, and ZG column. So after applying filter, we get an array, and we again convert each of the column into a data frame, and then we combine it using pd.concatenation function, and we set drop is equal to reset in we use reset index, because combining all the files can confuse the concatenate function, and what it does is it takes only one column of the file and appends all the data beneath it. So now we slice the label values, and if we want to print it, we can do this. And so you can see the labels. We don't want to see them now, so going ahead, we again do some now we splitting the test train data set, and by convention we take 30% of the data, and it should be 0.3 as the test set and 70% as the training data set, and we split it. And we now check the rubrics. At least one traditional machine learning algorithm and one deep learning algorithm applied and demonstrated. So in a traditional machine learning algorithm, I'm using a decision tree based classifier. We can either use the gradient boosting classifier or random forest classifier. First of all, we import all the classifiers and some important libraries like classification report and learning curve, and we use the random forest classifier with the number of estimators equals to 10,000, which means that there will be 10,000 decision trees will be made, and then their results will be summed, and this as a whole will give us accuracy. Now we apply the fit function. Now as the number of estimators are pretty high, we expect this to take a time. Meanwhile, we can explore some other rubrics. Algorithm. As you can see, this was my test submission, which I got 0 marks, but I hope to get passed after this video. And it is still in progress. So meanwhile, let me check the notebook which I previously run. So we got the accuracy of 55, around 55 for the neural network and 88% for the decision based tree methods. Coming back, as you can see the noise reduction, you can see this is the original value samples and this is the filtered signal. The filter signal has lower noise, very low noise as compared to the original signal. And let's look for a minute at the filter function. Where was the filter function? See here, from scipy.signal import L filter, we use the L filter, and if the n is large, the smoother the curve will be, and that means we get a smooth function. And if I change it to 100, the curve will be more smooth and the result will be more accurate. Meanwhile, we wait for the this tree method, and meanwhile let's just change a bit our neural network, adding some layers, adding some units here. Let's say 700, 600, and 3 to 1. The output here is 1 because we have a binary classifier. So one neuron is sufficient, and we use the ReLU activation in all of our hidden layers, and the softmax function for our output layer. You can see the data is still being modeled, and compile, and as we will compile this, we use the mean square error. We can also use the mean absolute error. The optimizer is SGD, standard gradient, stochastic gradient descent, and then we will fit the model, make some predictions, and we can check now its status. Still being done. Still being done. Yes. Let's check if we have some additional things that we can do with our project. Model evaluation. We can evaluate classification by. So, as a little information, I printed the confusion matrix, find the accuracy, precision, and recall, true positive rate, true negative rate, false positive rate, false negative rate, F1 score. The rest of the other I didn't do it, and since it's not a regression problem, I also didn't. So as we can see, the model has been completed, and now we can compute the prediction score of our on our test set. Let's see what we get here. We get a 86.3% accuracy, which is pretty good. Make some predictions, and let's see, print the classification report. As you can see, the precision is 87%, recall is 86%, and F1 score is 86%. And now we will print the confusion matrix. It is printed. We can calculate the true negative, false positive, false negative, and true positives. Let's see. So we get true negatives 2052, false positives 708, false negatives 139, and true positive 3311, which is a good score. We now build our feed forward, simple feed forward neural networks, and now we compile it, fit the model. Let's see what we get here. It's gonna take little less time than the decision tree based algorithm. We can see here the accuracy is very low. The neural network has not been able to classify it correctly, but the decision tree has successfully classified it. This is the main advantage of the decision tree models. That is why they are mostly used by data scientists in mostly in Kaggle competitions, and I personally like them very much. So let's see what we get here. We have a batch size of 320 and 5 epochs. Let's see, so we are close to 56. The mean square error is 0.44. So we now print a confusion matrix for our second predictions. We see that there's a pretty much little score. True negatives are 0. That means it is not classifying the class at all. False positives are 2760. False negatives are 0, which is good. True positives are 3455. We now print the classification report, and as you can see, the precision is 31%, recall is 56%, F1 score is 40%. Now we compare the performance parameter of the neural network model and decision tree based models. The performance model of I think I missed it. It is not neural network. It is a random forest classifier, as we have just seen above. Okay, so here they are, and this is not a good model, didn't give us enough accuracy, and this belonged to neural network as we had just seen. Okay, so now look at the rubrics. Where are the rubrics? Yes. uh, Here they are, and this covered the last rubric: model performance between different feature engineerings and models compared and documented, and at least one traditional machine learning algorithm and one deep learning algorithm applied and demonstrated. So I guess I have covered all the rubrics, and thank you very much for watching. I am also putting a link to download this file. You can download it and run it by yourself. I will also upload the dataset which you can use to improve the model. Thank you very much, and thank you, Romeo, for once again for putting up this great specialization. I really enjoyed it. Thank you.